Hello everybody, this video is on section 6.3 normal distributions. You should have already read the chapter and filled out the note sheet that I gave you, so hopefully some of this vocabulary is fresh in your mind. Some of the two things that you should have heard of before but maybe haven't looked at it in this way is mean and standard deviation. You guys know what the mean is. It's the average. The standard deviation you may or may not be that familiar with. Really quickly, the standard deviation is how spread out your data is. So just knowing the mean isn't enough. If you know the mean of your data, for example, I've got these three pieces of data here. Let's say they're test scores, a 25, a 50, and a 75. The average is 50. 49, 50, 51 is another set of data. Let's say another set of test scores. The average is also 50. They both have the same mean, but you can tell that the data is very, very different. This is much more spread out. The first group is much more spread out than the second group. So the standard deviation, if it's small, that means that your data is very clustered around your mean. If your standard deviation is big, that means your data is more spread out. So that's what that can tell you. So in this section, you're not going to be calculating means and standard deviations. You're going to be using means and standard deviations and applying them to help you figure out some probabilities that have to do with normal data that is distributed normally. So in your book, you have this picture. Hopefully you've read and looked at already and actually put into your notes. If data is distributed normally, that means most of the data is actually hovering very close to the mean, okay? So 68% of your data is within one standard deviation of the mean. So on this, the mean is in the middle, okay, whatever the mean is in the middle. 34% of your data is to the left of your mean, 34% is to the right. So that means 68% of your data falls within one standard. So if it were test scores, that would mean 68% of the test scores fall within one standard deviation of the average, of the mean, okay? 95% will fall within two standard deviations, and all but 0.3% will lie within 3 standard deviations. So these percentages are going to be very important when we are trying to figure out some probabilities of and some numbers of some people, not necessarily probability, but some percentages of some percentages of distributions, okay? So let's just do an example so we can see how this works really. So here's an example. We have blood cholesterol readings for a group of women are normally distributed. The mean is 172 milligrams per deciliter, I think that is, maybe, and 14 milligrams per deciliter is the standard deviation. So we've got 172 mean, 14 standard deviation. And then we're going to use, because it's distributed normally, we're going to use this normal curve to figure out how many, or what the percentage of women have readings between 158 and 186, okay? So let's go, I'm going to go back. Okay, so what you want to do is you'll want to set up this curve, draw it for you, and then we're just going to have to use this information and put some numbers on our curve, okay? So the mean is 172. That always is going to go in the middle, okay? 172 is in the middle, okay? Now, within one standard deviation of the mean is this first bar here. So what you need to do is you need to add 14 to 172. So that would be 186. And over here you would subtract 14 because you're within one standard deviation on the other side of the mean, which is 158. Then keep going. We're going to add 14 to get to the next standard deviation, which is 200. And then we'll just go one more, which is 214. And then we're going to go on the left side, subtract 14, so get to 144. And one more, 130. I haven't really drawn this to scale, but you get the idea. So here, remember that, we're going to use this to answer this question. So let me go back to the question. The question is about what percentage of women have readings between 158 and 186. 158 and 186. 158, 186. Well, luckily, There's 158 and there's 186. So that means this is the percentage of data. Use blue. Oh, no, green's good. So this, all of this, this is the number of people, 68%, because remember this is 34% and that's 30%. So 68% of the women are going to fall between 158 and 186. 58% of all women, their cholesterol is going to be in between those two numbers. Okay? The next question, so let me write that down there, so that would be 68%. And the reason we know that, I'll go back one more, is because of this chart. 34% is within 1 standard deviation of the mean. Okay, we are within 1 standard deviation of the mean at 186 and 158. Okay, going back to the second question. Reading less than 158 are considered desirable. About what percentage of the readings are undesirable? So, undesirable means it's going to have to be greater than 158, right? So let's go back. Greater than 158. So that means we're going to be talking about, I'm going to get rid of these squigglies. Okay, let's get rid of these squigglies. Oops, it's too big. Okay, and I'm going to add my own squigglies here with some of this. So that's going to be greater than 158. So that's all of this, all of this, all of this, all of this, and all of this. Okay. Well, we just need to add up. This was 34%. This is 34%. This is, and you guys can check your chart. I'm not going to go back. 13.5%. And this is 2.35%, and then everything less than 214 is 0.15%. So if you add all of those up, that is going to be the percentage of people who have undesirable cholesterol. That's not very good, is it? That's a lot of people. That's, I believe that's around 84% when we add all of that up. We will check it. Let's do it really quick. I'm going to do it on my calculator. 834 plus 34 plus 13.5 plus 2.35 plus 0.15. It is 84. So yes, 84% don't have very good cholesterol. That is not good. Okay, so if 84% don't have very good cholesterol, the desirable cholesterol would be this stuff over here. Well, we could add those up, or we can just say everything under the curve has to equal 100%, excuse me. So 84% is undesirable. That means 16% would be desirable. Okay. So the key to doing these problems is you have to sketch your curve and then put your mean in the middle, use your standard deviation to mark out these spots, and then it's really easy to just add up these standard deviation percentages, and you will have your answers to a lot of the questions, okay? Things get a little bit interesting, which is what the next video is about. If I ask you something, says, well, I want to know what percentage of people are between 140 and 150. Well, 140 and 150, 140 is like right here, and 150 is right here. I don't have a nice, I don't know what that percentage is. Okay, so that's where some z-scores are going to come in, and that's what the next video is about.